really looking at merging this idea of differentiation and integration, and then kind of looking at, well, how does that affect the absolute maximum? How does that affect the, or absolute minimum? How does it affect a relative maximum or minimum? How do we write equations of tangent lines and things like that? So we're going to do a little review, and then we're going to do some problems from Delta Math. So first of all, I know you've written it down several times, but a tangent line, way we can write it is y equals f prime of a. And remember, f prime of a is generic. It's not necessarily referring to anything. It just means the derivative at x equal a, whatever that derivative is, whatever that numerical value is. X minus a plus f of a. Remember, this is the value of the function at x equals a. And so that's the tangent line. So when we're asked to find it, the pieces that we're filling in on this is we're filling in a number for this value, we're filling in a number for this value, and we're filling in a number for this value. So those are the numbers that we're filling in. So when you're asked to find the equation of a tangent line, you know that's what you're looking to do. Now let's look at the idea behind the chart. But we're going to represent it a little bit different. We know, you should know, that when we draw the chart, that we have something that looks like this. Now, you know, I can have you fill this out. If this is increasing, this is positive, and we don't fill anything out there. This is decreasing, this is negative, and we don't fill anything out there. If this is concave up, this is increasing, and this is positive. If this is concave down, this is decreasing, and this is negative. I know that generically, we have put f prime, and f double prime. But that's not always the way it's going to work out. It could be that I make g equal to some integral of h of x. That means this would be g prime, which would also be h. That means this would be g double prime, which would also be h prime. Remember that if you're given a graph, if you're given some kind of a graph, say this is the graph of f, and let's say start here at a and go over here to x, and let's say g of x equals the integral from a to x of f. So say we have something like this. That represents the area under the curve. Whereas g prime of x would equal f of x, which is the value of f. And then finally, g double prime of x would equal f prime of x, which would represent the slope of f. So you got to kind of pay attention to where we are and what we have and what we're going to try to do with these functions. And they all kind of mush together, where we start talking about a function defined as an integral, but then we start doing derivatives with it right away. Remember that to find an absolute minimum or maximum, what we're going to do, the first step we're going to do is find the critical numbers. When the derivative equals 0 or is undefined. Second thing we're going to do is make a table. With the endpoints and the critical numbers. Third thing we're going to do is calculate what I'm going to put down as y value. Could be another letter, but just the y value. And the fourth one is answer the question. So that's how we're going to find an absolute minimum and maximum. That's not changed. That's stuff that we had from earlier this year. Now, we're going to talk about this. We're going to do a couple of examples, and I'll try to maybe do one from each of these sections, because here's your assignment over here. I'm going to do one for each of these sections. If you're like, I feel like I got this, go off and try to do the problems. And if you have trouble, come back and watch the examples. That would be a fine way to deal with it. So let's just look at some examples. And I'm going to pull this up. I'm going to do my best to just rearrange this a little bit. I just got to get it so I can see everything on here. So let me do my best to pull that up. Okay. All right. So here's the first problem. And I'll show you how it relates to the chart and what my thought process is on it. I'm not necessarily going to rewrite the whole problem. I certainly am not going to draw that graph, but you get an idea. So g of x is the integral from 4 to x of f of t dt. And it's kind of going, compare these things. What are these values? Are they greater than 0, less than 0, or equal to 0 for all of these? And we're supposed to figure out g of 4. Well, g of 4 would be the integral from 4 to 4 of f, which clearly is 0. The area under the curve from 4 to 4 is just 0. Can't be anything else, right? G prime of 4 is just f of 4. We just talked about that was f of 4. F of 4 is also 0 in there. It's right there. This is the graph of f, so f of 4 is equal to 0. Finally, g double prime of 4 is equal to f prime of 4, which is clearly the slope at 4. Well, the slope of this graph at 4 is clearly less than 0. It's negative. It's a graph that's falling. That's how I'd answer that question. The other examples will be really, really similar to that. So let me go to a tangent defined function. So let's look at this. This one says, okay, let's write the equation of a tangent line. We know g of x is equal to the integral from negative 9 to x of f of t dt. Generally, if x is in the integral, t is going to be the variable down here, because we really don't want to confuse which variable we're talking about. It's saying figure out the tangent line when x equals negative 9. Okay? So, I wish I would come up with I might check and see if I can get a new problem. Here, let's do this one. It's the same kind of thing, and it only changes one piece for you. It changes that this is 9, and it changes that this value is now 7 that we're looking at. Okay, so here's what we need. We need g of 7, because we need to figure out what the heck is that. What is the point that we're looking for? Well, g of 7 is the integral from 9 to 7. That's important, starting at 9, going back to 7, of f of t dt. Notice that that's this area right here from 9 to 7. It's that space underneath the curve if this is the graph of f. Notice that that's below the x-axis, which would, you'd think, well, maybe that's negative. But it's going from 9 to 7, so it's going in a negative direction. So together, that's a positive. So if you think about that, that's 1/2 -2 times -5, which ends up being 5. And it's -2 because we're going from 9 to 7. It's -5 because the height of this is -5. So that's one piece we need. The other thing we need is we need to figure out what is g prime of 7. Well, g prime of 7 is f of 7 because g prime is equal to f. G prime equaling f, f of 7 is equal to 0. It's right there. So the slope is 0. So if I were going to write the equation of this tangent line with this information, I'd write y is equal to 0 times x minus 7 plus 5. I just put the pieces in their place. Hopefully that makes sense. All right. Now, let's look at this one. This is a little bit tougher. Notice this one is asking for an absolute minimum because it says what is the minimum. So what is the minimum? Without the word relative, you know that that's the absolute minimum. You got g of x is equal to the integral from -7 to x. So we're starting at -7, going to 7, t dt. And our interval that we're working with is from -7 to 8. Okay. So the first thing we're going to do is find the critical numbers. Well, the critical numbers are going to be when g prime of x, which equals f of x, is equal to 0 or undefined. This is the graph of f. And we're only working with the interval from -7 all the way up to 8. So let's talk about those. That would be when x equals -7, but we're going to cover that with the because it's touching the x-axis right there. Looks like I'm going to say that that's 2, -2. Let's say that that's 1. I don't know if they told me that, but that's what we're going to go with. I think on an AP exam, they'd actually tell you that's -2, but if we zoom in, that's where it is. We're going to say 4. That's another place that f equals 0. And 8. Now, what we're going to do is they give us the regions. They tell us this region is 12 as an area of 12. This region is a 12, and this region is 10, and this region is 8. Well, what we're going to do is we're going to make a table of values with this information. Our table of values is going to be x here. We've got -7. -2, 1, 4, and 8. All the critical values and the 2 endpoints. Notice that this is going to be the integral from -7 to x of f of t dt. So like if you kind of thought about this, this would be the integral from -7 to 7 of f. This one is the integral from -7 to -2 of f. This one is the integral from -7 to 4 of f, to 1. This one is the integral from -7 to 4 of f. And this last one is the integral from -7 to 8 of f. Well, we can get these values because we know that this integral right here is the area I'll say area loosely, under the curve from -7 to whatever x value it is. So if we think about this particular one right here, that's 0. If we start at -7, end at -7, we get 0. If we start at -7 and we go to -2, we have -12 because it's below the x-axis and so on. If we go with the next one, notice now we got -12, we got another -12, which is -24. Now we get to add. So let me back up to that. This one would be -12 plus -12 to get -24. This one would be -24 plus 10 because now we've gone above the x-axis, or -14. And the last one is -14 plus -8 because we've gone below the x-axis again, or -22. Now it says, what is the minimum value? So now we have this chart. The minimum value for G is -24 and occurs when x is equal to 1. So the actual minimum value is -24. It occurs at -1, but the actual answer is -24. And if I show the solution, that's what they're going to tell me, and they do the same kind of thing that I do on there. Okay. Same kind of thing with this one, a maximum value. You're going to go through the same kind of thing, only now with this, we are going to calculate areas. Okay, so we're going to calculate areas. So just know that won't be any different. And the last thing is you're going to get inferences from velocity. Remember that when we did these steps, this is the position, this is the velocity, this is the acceleration. We differentiate to go up, integrate to go down. So this is oftentimes x of t, this is x prime of t, which is equal to v of t. This is x double prime of t, which is equal to v prime of t. Which is a of t. Okay, so just know that those steps stand in there. So a particle moves along an x-axis. What that means, this idea of a particle moving along an x-axis, is it's on a road. So it's on a road going left or right. So think of particle moving along an x-axis is it's going on this road somewhere back and forth. So this is some road. Okay, so this is some road. The velocity is given by this graph. Find the total distance traveled. So the total distance traveled during 0 to 10. Well, notice, if we think about the total distance traveled, we start somewhere, right? So if we start right here, let's just say that this is where we're going to start. Notice that starting here, going to 1, this space is 1. If I calculate that value, it's 1. And it moved to the right 1 unit. So this is when, this up here is when t equals 0. So when t equals 1, this distance that we traveled was 1. Now what happens? Now from 1 to 14, we go back the other way because all of this is negative distance, which means we start going this way. And now what we're going to do is we're going to go back this way. And we're going to go back this way all the way to when t equals 14. This space represents this area underneath this curve. Well, we can kind of split it into a couple different triangles. I'll do that with you here. So it's 1/2 the base of this triangle, which is 4, and the height of this triangle is -6, plus the area of the rectangle, which spans from 4 to 10, so that's 6 times -6, plus, and then we got a last triangle here, which is 1/2, 4 times -6. Notice that made a rectangle as well. So you got 2, so you got -12, -36, -12 more. So together, between 1 and 14, we went to the left 2460. So we went to the left 60. Now, actually, we didn't have to go that far, right? Because we're supposed to only go to 10. So I kind of messed that up. So if we only go to 10, what that means is we would have not had this part. We would have had that, which means our total distance traveled would be -48, or total distance traveled to the left. So here's what happened. We went to the right 1 unit, and then we went to the left 48 units. So our total distance traveled is equal to 49 units. And if I go to show the solution, they're gonna start. Whoops, what did I do? Oh, I calculated that one wrong. That was a span of 3, not 4. So sorry about that. That was a span of 3 here, not 4. So this would be -9 here, which makes this 45. I'm sorry about that. I didn't count it right. So we went 45 to the left, so overall we went 46 units. So that's our total distance traveled. The other way to think about it is what they did here. If distance is, distance is non-directional specific, then what you can do is you can do the absolute value and move everything to be positive. Negative parts of the graph turn to positive, positive parts of the graph stay positive. Hopefully that makes sense. Let me know if you have any questions, and I think you guys will be set.